After completing a 3D model, we will assign the loading. So select loading and go to load case details. Before that, we assign the reference load definition, add, that is dead load, add, live load, add, close. Now go to dead load. So first of all, we will see the loading condition of this warehouse. We have so here we see the loading condition. This is length of the building width. So first of all, see the loading condition. Total dead load 5 psf. This is including the roof sheet and purlin. And live load, this is assuming 12.5 psf, and based on that roof dead load is 5 divided by 20, that means I convert the kilonewton. Same way roof live load, convert the kilonewton per square meter. Now see, this is our C9 multiplied by C12. C9 is our 4.5 meter PA and 5 our loading condition. In that case, from here we can get the dead load and also can get the live load, and this is the end bay loading condition. So we input the value dead load and live load, intermediate frame and end frame. So dead load, add, that is self weight, add, and member load, the intermediate load here, dead load 1.13 kilonewton per meter. So minus 1.13, that is GY direction, add. Same way half of this load 0.56 to 5, 0.56 to 5, that also GY, add, close. Now we assign live load, add. Now see live load 2.81, that is member load minus 2.81, GY direction, add, half of this load minus 1.401, add, close. Now we will assign this load. So assign to view, assign, yes. Now select this one, go to view from top view, select this node this way, this way, this way, and this way. Go to new view, okay. Go to isometric view, view from Z, select the intermediate frame, go to isometric view, assign to selected beam, assign, yes. Same way live load, assign to selected beam, assign, yes. Go to whole structure, top view, select this frame and this frame, go to new view, okay. Isometric view, go to Z view, select this beam, go to isometric view, assign to selected beam, assign, yes. Same way, select it, assign selected assign. Now display whole structure. This is our dead load and live load. Now go to Seismic definition. Add. We provide UBC 1994 zone factor zone value 0.15, importance factor 1. This RWX value 6 for steel building, 6, site coefficient 1.5, and city value no need this value input here. Add, close. Now add and go to reference load, dead load, y direction, add, close. Now go to load case, add, close. Now see our load case here. Now we assign one by one. Go to dead load, add, reference repeat load, reference load, dead load, add, close. Same way, live load, add, repeat load, reference load, live load, add, close. Now see load is acting. Now see load is acting. Now select, go to X, earthquake X direction plus, add seismic load X direction, add, close. Earthquake X direction negative, add seismic load X direction negative direction, add, close. Earthquake Z direction, add seismic load Z direction positive, close. 1. Same way, earthquake Z direction negative, seismic load Z direction and negative sign, add, close. Now earthquake load assign. Now we'll assign the wind load X direction. So before assign the wind loading, we see this is our windward wall, this is windward roof, this is leeward roof, and this is leeward wall. So first of all we'll see how to calculate this load as per BNBC. So let's see, using this Excel sheet we will see how to calculate the wind load. Say this is building length 4.5 meter, 7 bay, and multiply by 3.28, that is 103 feet. Same way width 15 meter, 3.28, and building height 5 meter, and eve height 1.5 meter, average height this 18.86 feet or 5.8 feet, bay spacing 4.5 meter, gable spacing 3.75 meter, spacing of purlin 3.28, and dead load 5 psf, live load 12.5 psf, and wind load to 10 km per hour. Height exposure coefficient Cz, this value will get from exposure and gust coefficient here. Now see our building height 5.8 meter, but as per BNBC the value show 3 meter, 6 meter. So what can I do? If we get if you want to get the 5.8 meter, so we can get using linear interpolation. So y1 value 3 and y2 value 6, and this is exposure A. So select, copy this one, x1, and 6 for this one, and from this we can get the CZ value. Same way we can get the last coefficient 5.8, this one, and interlink this value from here, this x height and exposure coefficient CZ, and same way gust coefficient CG, this value, and this is automatically generated as per our inputted data, and it also the degree from this shade structure, it also automatically generate, and average height HL, length width ratio LB, L by B, A, and coefficient CP L by B windward wall. This is as per BNBC from table we can see, and this is windward roof 0.413. So let's see how we will calculate this value. Now see, HA by H divided by L, H by L value 0.38. So go to table, this is windward roof, and H by L, see, is less than or equal 0.3, but our H by L ratio 0.38, and our building inclination degree of building 11.31. So using this value and this value, we can get this windward roof, this value. Let's see, from linear interpolation we can get this value. This is our degree, and see, our degree is 10 to 15, so we can get 11.31 value from using interpolation formula from 10 to 15. That's input 10 and 15. Now see, the H by L ratio 0.3, but our value 0.38. So we also get this value from interpolation. So what can I do? Input here 0.3 value and 0.38 value within this range, 0.3 to 0.5. That's why I input 0.3 and 0.5, and see, 0.3 value is 0.2 positive to 0.5 value 0.9 minus negative. So input here 0.2 and negative 0.9. So interpolation formula we can get this value, and we incorporate this value from x1. Same way the 15 value, 10 to 15 value is for H by L ratio minus 0.9. From this we can calculate the CPX minus 0.413, and we will input this value is here. Same way, this is L by B leeward wall. We can see leeward wall 0. Our L by B value is 0.48. So see, 0.48, but the value is 1 to 0.65. In between we can get this result. So select input here 0.1 and 0.65, and input the value 0.5 and 0.6. From this interpolation we can get this value, and we input the value here, and see internal peak pressure coefficient CP If opening is more than 10%, then use this or use 0. So use this one, and all things are generated automatically. Now see, this is generated automatically, and see, this is our value windward wall. This is our bay spacing 4.5 meter. That's why multiply this, multiply by this value, and multiply by this bay distance. This way we can get this value, and same way this get this value, and we will input this value in our stat model. Now see, first of all we provide wind load x direction, add. See, windward wall. So member load windward wall, that is ZX direction, and the value 5.88, add. Now see, 5.88. Now this is windward roof, the value is 1.58, that is local Y, add. Same way, this is leeward roof 3.34, that is local Y, and this is leeward wall 2.53, and that is ZX direction 2.53, add. And we also provide half of this load for A in bay, so that is we input 2.941, that is also ZX global X direction 2.941, add. That is, this is Y direction local Y, and 0.789, add 1.671, that is local Y. It is 1.26, that is ZX direction 1.266, add. Now this is our side wall, so also input the value 2 point, that is GZ global Z direction, and value 2.79 for intermediate frame, add. And negative direction, add. And for 8 bay, half of this load 1.393 GZ, add, and input negative sign, add. Same way we will assign the WZ direction, add. assign. Go to WX and WZ. Now we will assign these two value, the two direction, wind X direction positive and wind Z direction positive. So select top view, go to select this frame, this frame, this frame, this frame, this frame, and select new view. Okay, go to Z isometric view, go for view from Z. Now we'll assign. So this is windward wall, so select this one, yes. Okay, now assign to selected beam, assign, yes. This is windward roof, select this way, assign to selected beam, assign, yes. This is leeward roof, assign to selected beam, assign, yes. This is leeward wall, assign to selected beam, assign, yes. Now we provide WZ direction, windward roof, select this way, assign to selected beam, assign, yes. Leeward roof, assign to selected beam, assign, yes. Same way we provide the side wall, GX direction positive, select this one, assign to selected beam, assign, and this is negative, assign to selected beam, assign, yes. Now see isometric view and go to top view, whole structure, view from Y, select this end way and this end way, right click, new view. Okay, go to isometric view, view from Z, and select the windward wall, assign to selected beam, assign, yes. This is windward roof, assign to selected beam, assign. This is leeward roof, assign to selected beam, assign. This is leeward wall, assign to selected beam, assign. And the same way we provide the windward roof, assign to selected beam, assign, yes. This is leeward roof, assign to selected beam, assign, yes. Now go to isometric view. Now we will assign the side wall from global Z axis, that is positive, so select this column, assign to selected beam, assign, yes. Same way, that is negative, select this column, this column, this column, assign to selected beam, assign, yes. And end bay column, that is positive, this column and this column, assign to selected beam, assign, yes. Same way, this column and this column, negative direction, assign to selected beam, assign. And this is windward wall, that is select this column, this column, this column, assign to selected beam, assign, yes. And that is leeward wall, select this column, select this column, assign to selected beam, assign. And this is 8 column windward wall, assign to selected beam, assign, yes. and that is leeward wall and end way. Assign to select beam assign. Yes. Now we will input the side wall Z direction, that is positive. Select this column and this column, positive direction. Assign to select beam assign. Sorry, that is this one. Assign to select beam assign, and this one, this column and this column. Assign to select beam assign. Yes. Now see, our all load are acting. So go to display whole structure. Now see, our all load are assigned in WX plus direction and WZ positive direction. Now we go to utility, command file, save. It will take some time. Now go to our load setting. This is our wind load X direction. Select this one. Now see, WX loading condition is here. So select this one, copy and paste this one, wind load X direction negative, and paste here. Now see, we'll only change the global X direction value negative sign. So input here negative sign, Y direction as it is, only Z direction, windward and leeward wall will be negative direction, all other side wall also same. ZX negative sign, ZX negative, and side wall as it is. Same way we copy this WZ positive direction, copy and paste here. Same way we input the negative sign, the windward wall and leeward wall, and all other are as it is. So ZZ negative sign, ZZ negative sign, and GX side wall, that is as it is. So save this one and close. Now go to loading, load case details. Now see, WX and WX negative, all load are acting. Let's see. Same way, WZ plus and WZ minus. See, the load is acting. So our load assign is done. As per our BNBC, I have input the load combination. So select this one, Ctrl C, copy, and once again go to utilities, command file, the load combination, load case 10. Now we input the load combination 11 to remaining as per BNBC 2006. Ctrl V. Now see, 11, 12, 13 like this. 24 load combination is here. So select Ctrl S and close. Now go to loading. Now see, the load combination also here. So go to analyze, load list, and select 11 to 24. Okay, now command analyze, add, close, run analyze, save. Go to OK, done. Now go to design, and we input the code, design code AISCLRFT, define parameters, we input the yield strength 345000 kilonewton per square meter, the member yield strength, add, we input the UNB, that is 2.6 meter, add, and UNT 1 meter, add, close, moment, check code, add, take off, add, close. Now yield strength, all member are same material, so select assign to view, assign, yes, and UNB, go to view from Y plus, select this frame by this way, right click, new view, okay, go to isometric view, Z view, and select this way, assign to selected beam, assign, yes, UNT, assign to selected beam, assign, yes, display whole structure, check code, assign to view, assign, yes, still take off, assign to view, assign, yes. Once again go to analyze, run analyze, save. Go to post processing mode. Before that we want to check the loading, the earthquake load is acting or not. Let's see. Now see, this is X direction, same way, this is X direction but negative sign, same way, Z direction, and so earthquake load is acting. So go to run analyze, go to post processing mode, done, okay, go to utilization ratio. Now see, we can here we can see the value which are more than 1, that is need to redesign, and which is less than 1, lower bit 1, like this is comparatively lower value from 1, so we can increase this decrease this size for economic design.